Hello, my name is Srishti Gupta, and I will be presenting my research titled Instagram of Rivers Facilitating Distributed Collaboration in Hyperlocal Citizen Science, which was co authored by Julia Jablonski, Chunhua Tsai, and John Carroll. Citizen science refers to participation of members of the public in scientific research. Citizen science is a popular research technique in domains such as environmental science, where scientists usually need to collect large volumes of data, which may not be feasible for a small research team. Therefore, citizen science not only helps scientists do better research by increasing the spatial and temporal breadth of data collection, but also helps engender socio-technical affordances such as increased community knowledge about science and data literacy, increased community engagement, and social capital. However, citizen science groups often face common socio-technical challenges which have been repeatedly discussed in academic literature. Some of these challenges include uncertainty about citizen science data quality, retention of participants in projects, and lack of appropriate technical infrastructure. Innovations that address these socio-technical challenges can be shared across different citizen science groups through peer-to-peer collaboration. However, most citizen science groups practice in isolation and end up reinventing the wheel when it comes to addressing these challenges. Encouraging distributed or peer-to-peer collaboration between citizen science groups can potentially streamline citizen science activities by ensuring that groups don't spend unnecessary resources and time on addressing problems that can be otherwise easily be resolved by sharing and exchanging information and resources. The goal of this research was to understand if facilitating distributed collaboration can help improve citizen science practices. For this, we conducted a qualitative user study of a watershed networking application called Water Reporter. The goals of this study were to understand goals and benefits of distributed collaboration and how appropriate technological infrastructure can support and improve distributed collaboration. Water Reporter is a citizen science application that supports watershed monitoring activities. It has an Instagram style of interface and some of the main functionalities of this app include data collection, which is done by uploading images and corresponding data form, data visualization features, and social interaction features where users can like and comment on the images. Water Reporter was not built to support collaboration, but its social media design allows its users to appropriate its function to carry out collaborative activities. Hence, we use this app to understand the possibility of technology-mediated distributed collaboration to help improve citizen science practices. We used semi-structured interview protocol to interview project leaders of different citizen science water quality monitoring groups across the US. We conducted 14 interviews, out of which 8 were with Water Reporter users and 6 were with non-Water Reporter users. This helped us compare how collaborative activities differed between groups using collaborative technology and groups that did not use any collaborative technology. We analyzed the interviews using inductive thematic analysis method. The data analysis led to 4 main findings, and I will be discussing 2 of these findings in this presentation. Goals of distributed collaboration. So all citizen science groups collaborate either regionally, nationally, or both. So all groups had clear goals of collaboration. While both user groups acknowledged the importance of distributed collaboration, more established groups find it easier to find new groups across the nation to partner with, whereas smaller or newer groups often focused on collaborating more regionally. Out of these smaller groups that used Water Reporter, they gave instances where the platform had helped them make connections that they wouldn't have considered or known otherwise. In the code presented here, P5 is a member of a small citizen science group and a Water Reporter user in California. Since most Water Reporter users are based on the East Coast of United States, P5 wouldn't have considered looking for collaborators in such a different geographic region. Though unanticipated, these collaborations facilitated by Water Reporter transpired to be beneficial. On the other hand, non-Water Reporter users usually use their existing regional networks to collaborate and did not anticipate need for more distributed collaboration in other geographic regions. Social interactions among citizen scientists have been observed as an important motivational factor in online citizen science projects and within field-based citizen science project. Our interviews elucidated the role of social interactions between distributed citizen science working in different groups. Since Water Reporter has been designed as a social media platform, its users could easily identify benefits and challenges of such social interactions. However, interestingly, non-Water Reporter users also alluded to the need to facilitate such distributed social interactions. In the quote presented here, P12 talks about an integrated database that her group was building with their partners and wanted to add a social interaction feature for volunteers in different groups to communicate with each other. We discussed the role of Water Reporter as a mediator for distributed collaboration through the lens of activity theory. It is a mediator because it assists citizen scientists in various activities such as data collection, interaction, and data mapping. These activities can be achieved without Water Reporter too. However, having a mediator changes the process and outcomes of these activities. For instance, the observational data collected through the Instagram style interface changes the way data is collected and leads to additional socio-technical outcomes such as greater transparency and interactions. Water Reporter's mediator design also creates visibility, allowing users to discover other groups and their work in the region. This affordance led to unintentional benefits, which the groups weren't necessarily looking for, but the presence and use of the particular design features augmented their activities. Another implication was that this design was the transparency provided by the tool for its users. The social media design allowed users to see and comprehend each other's activities as they occurred. So this can help create awareness and provide mutual knowledge and common ground to all collaborators. In citizen science, such awareness can be helpful in providing a sense of acknowledgement, sense of community by building a common ground and providing shared feedback. As a way forward, we recommend implementing the design of collaboratories for citizen science. Collaboratories refer to virtual labs, which was a design concept to enhance collaboration between distributed scientific teams. Hence, we suggest exploring how concept of collaboratories, which has been successfully employed in the scientific community, can be contrived to provide a similar collaborative environment to citizen scientists. A collaboratory for citizen science could be social media style design that allows easy data collection, database to directly parse and store data, social interactions, discussions, data analysis, and interpretation features. Even though skills and activities of professional scientists differ from citizen scientists, scientific collaboratories can be used as a model to guide the design of citizen science collaboratories. Thank you. And if you have any further questions, you can reach me at this email.